I want to take a few minutes to talk about color and what is it and how is it created. Color is light bouncing off of surfaces and appearing to us as colored. Isaac Newton discovered color. He was a mathematician, astronomer, theologian, author, and physicist. In 1672, Isaac Newton darkened a room by closing a window shutter, but exposed a small hole for sunlight to come through. The light hit the path of a triangular prism of glass and divided the white light into various colors of light. These colors could then be recombined back into white light through a second prism. The sun looks white to our eyes, but sunlight itself is a mixture of many colors all mixed together. The colors of the rainbow show up in order are red, orange, yellow, green, blue, indigo, and violet. The prism works because the different colors of light travel at different speeds inside the glass. The different speeds of light create wavelengths, which allows the colors to organize and spread out instead of remain mixed up. Violet travels the slowest, so it is at the bottom. Red travels the fastest, so it shows up on top. So how do we get a rainbow when the air is full of water? The raindrops act as a prism for light to travel through. The rainbows are circular in shape because the raindrops are spherical in nature. A wavelength is the distance between crests in a wave of energy. This is measured in nanometers, which is 1/1000th of a meter. Differences between colors involve tiny differences in wavelengths. Violet is the shortest wavelength. Green is the middle wavelength. And red is the longest wavelength. The visible spectrum is a certain range of wavelengths of radiant energy that can be distinguished only by the human eye. So if you see here, this is the range of what we can see as a human right in here. In the electromagnetic spectrum, only a very small portion of all radiant energy can be seen by humans. We are unable to see energy in microwaves, X-rays, ultraviolet light, and radios. White objects reflect all colors. Objects do not have color of their own, but the ability to reflect certain rays of white light, which contains all the colors. Black does completely the opposite, where black absorbs all colors. A simple way to remember this is to think about getting into a black car during the summertime. It is often too hot to touch, even in the interior. Heat is produced by all the radiant energy being absorbed by black. Red objects absorb all colors except red. Red is then reflected back to our eyes. I want to talk about two color systems that are important for us to understand in this course. I want to talk about the additive system and the subtractive system. The additive system is where lights projected from different sources mix accordingly to create other colors and ultimately white. This system is most commonly used in television, computer screens, stage design, photography, and interior design. The RGB colors are the additive system primary colors. Red, green, and blue overlap, creating a white light. Red, green, and blue overlap to create a white light. When two primaries are mixed, they produce different colors, such as yellow, cyan, and magenta. If a painter actually mixed these colors with paints, they would create a muddy effect, not light. So as you've been doing your blog entries and you've been selecting colors from your color aid paper, which is a subtractive system, it becomes challenging because when you look at your image on your phone, that is an additive system. So it's very difficult to translate across both systems. The subtractive system is the one that we are most closely identified with as artists. In the subtractive system is where pigments combine, producing filters that ultimately reflect less light. This eventually leads toward a gray or black. Our typical 12-step color wheel is subtractive. The color aid paper is also subtractive. Any paint mixture is some degree subtractive. The mixture will always be weaker than at least one of the original colors. So you can see how all these transparencies, as they overlap these transparent colors, they get darker and they get muddier. And we would see that if we mixed these colors as well with paint. The painting primaries are also part of the subtractive system. The painting primaries are CMYK, which stands for cyan, magenta, yellow, and black. These are the colors used in the printing process. Both the painting and the printing primaries are used mostly by painters and studio artists. So if you think about printing, especially if you are doing any sort of hand printing through printmaking techniques, you know that if you need to get multiple colors in a design, you need to create separate plates. So in the printing process, an artist would actually create a blue plate, a cyan plate, a magenta plate, a yellow plate, and a black plate. And as they overlap, as they are printed, they create multiple range of colors. So this gives you an idea of the different color systems, how color is created, and how we see color in our natural world.